Before I start with that short introduction from my side, Christian Kurz is my name, or just Chris. I'm a FAE at the company Nordic Semiconductor, and I'm usually have to work with Zephyr a lot because if I open the first slide, you see already that Nordic is working with an NRF Connect SDK, and the main source here is basically Zephyr. So Zephyr is basically the core behind our SDK, and what we are doing is we basically work with a fork and add additional repositories to the SDK, which gives our customers a benefit. So before I continue, question to the audience: who is working already with Zephyr? Who is working with Zephyr on the NRF Connect SDK? Who has never worked with Zephyr? Cross check. Okay, at least a few. So for the few, maybe this slide is quite interesting because here I'm trying to show how a Zephyr project looks like. So if I want to do my application, I basically use the code base which was installed from the SDK, and with kconfig we can add software modules to our own project beside the code which you write. And on the other side, we want to make the hardware independent from the software project. So this means if I change the hardware, I don't want to touch the C code. And the easiest way to do this is using device tree. So this is basically a concept of working with the hardware. And that's quite important because if you define a hardware, the hardware definition for sure contains device tree definitions where the LED is connected to which GPIO, but it may also has some information about which software modules should be added if a certain application is done. And this is usually done in board definitions. Zephyr is coming with a big list of boards, predefined boards. So there are more than 540 boards included, and this is already old information. I did the number a few months ago, and for sure this has already changed. If we think about ARM boards, there are much more than 390 boards included. But you can also define your own board. So if you work with the dev kit, that's perfect because all the information about the LEDs, the buttons which are connected to the device are there. But if you have an own application, you may do an own board definition and place it in your project folder. Okay, now the bad thing is there will be a new hardware model. And Zephyr will introduce this in the next release, and that may cause some problems. Not with these boards here, with the predefined ones, because the migration is done by people from the Zephyr community. But if you have an own board, you may see that switching from an older version to a newer version, suddenly something is not working any longer. And the reason may be the hardware, the new hardware model, which is introduced here. I focus a little bit more on how to use it. My colleague has done a presentation at the Zephyr Meetup in Cologne in January, and if you're interested in the details there, you can watch the recording. In the last slide, I have the link to this YouTube video. So I'm speaking about old style, new style. So the better word for it would be hardware model version 1, hardware model version 2. So till Zephyr version 3.6.0, you will still use the old way to define a board. 3.6, this is the current latest release that is available. If we go to the main branch, you will already see that in the main branch, the new hardware model is already included. If you work with Zephyr main branch, you use it already. So then you will see that the folder structure is suddenly done in a different way. Instead of using the architecture, for example, ARM boards, they now list this vendor-wise, which makes sense, because previously in the ARM board we had more than 300 boards, and it was quite hard to find stuff. And here, if we go now to the boards Nordic folder, it's much easier to find at least the boards from Nordic Semiconductor, but that's also true for the other companies. So this is just one minor change. A bigger change is that the implementation, the realization of the hardware model is done in a more clear way. So the old way, we had the possibility to emulate SoCs. As a semiconductor company, we usually want to create a development kit and use this development kit to emulate different devices. So here, with these 3 boards, we have an example. We have the NRF52DK, where an NRF52833 device is on. And we can use this board to define that we want to work with this device. But we can use the same board and emulate a 52810 or 52805 device on the 833 device. So this is just spins with less peripheral, with less memory. And in the board definition, we basically define, okay, this is the device this is the SoC which is on the board, that has less memory, that has less peripheral modules, and by this we can use the DK to emulate it. The bad thing here was, okay, now we had to define 3 boards. The new concept fixes this because it only has one DK, and instead of having the board definitions in separate folders, we basically place it in one board folder. To make a separation between the SoC versions, there's a new file, board channel, and here basically the SoCs are mentioned. There's also a config where the appropriate software part is added to the project. Okay, but there's more. Board revisions. So if I have a dev kit, maybe over time the functionality is changing. And then I want to define different versions of a board with bug fixes, with new features that were added to the board. Trust zone support. Trust zone is quite interesting. Trust zone basically is offered by ARM for ARM Cortex-M33, for example. So here you can define if the CPU should execute a certain project in a secure domain or a non-secure domain. You basically do a split between the peripherals, the memories, and define these parts are only accessible in the secure domain, while the other parts that are defined are accessible in a non-secure domain. And that's basically done in a board definition. That's something we have included here. A main driver of the new hardware model is multiple SoCs on a board or multi-core solutions. If you have an application, a product, where an MCU is used, where maybe 2, 3, 4 cores are included, or even if we speak about a solution where on the dev kit, 2 chips, 2 microcontrollers are used. And on our side, this happens, for example, with the cellular IoT solution, where we have a small Bluetooth device beside it, and that could also be handled now with the new hardware model. Okay. The main change here as a user is really how to define to which board should be used when you do a build. And for this, it is important to understand the board terminology. And here an example is done from an alert module. So the example is defining more stuff than really exists. But it's fine to basically understand what the parts of the board target basically is. So we have basically the board name, that's the development kit name. We can define a revision, and then we use slash, define the SoC, slash, define the CPU app, the CPU cluster. So CPU cluster, for example, is, if we take a look on the 5340 device, this is a dual core device. So we have here an application core and a network core. And here we basically define for which core this project should be built. In this case, this would be the application core. We could also select the CPU net, and then the application would be compiled for the network core. Variant here, this is basically NS non-secure domain. If TrustZone is implemented, we can define this. So board name, board revision, board qualifiers, that's basically the part here. And the complete name is the board target. I have also added here an example, a real example with our cellular IoT device. And here we basically see how we could access this. And here we also see that some parts of the name are optional. A CPU cluster does not exist on the 9160. Because of that, nothing is mentioned here. I have mentioned here the build instruction, the command line instruction, which I could use for a build. And what you see here is that I have not mentioned the revision number, despite it is mentioned in the board YAML file. In the board YAML file, there's also a definition which default version should be used. So usually this is the latest one, the latest version, but there are more possibilities. So it would be possible to define that the exact version number should be used. It can be defined that a fuzzy version number could be used, and depending on the settings here in the board YAML file, the appropriate version number would be used, or you will see an error message during the compile output. One example, my thought then basically was, okay, what if I do not really know the stuff here, the board qualifiers? What should I do to get quickly some information? And the easiest way I found out was basically if you do a west build, and if I use only the board name, then you will get an error message, and the error message basically tells you which valid board target names exist. And by this, it's quite simple to find out what's available there. And here we basically have the NF91DK and NF9160. So this is basically the application core running in the secure domain. We have the NF9160DK, NF9060NS, non-secure domain. And this DK has also the 52 device on its board. And here I could also do the definition that the project should be done for the 52 series device. Another example, which will come in June. So one of our new devices, the NF54L15 PDK, we define here the device. We define that it should run on the application core in the secure domain. And the nice thing is that there are some config symbols available, which helps you to print out the board name. So I use basically here the Hello World project from Zephyr. That will be done in a way that the config board target will be output. And you remember board config, the board target, this is really the complete name. So what we basically get is the complete name, including the version number, the SoC, and the CPU cluster that is used by this device. And beside the board target, we also have the config board name, where only the DK name will be output. The board revision can be separately be accessed, and the board qualifiers can be accessed by this and used in your application. More examples. The most simplest one, and this time I basically show the old style, the version 1 versus the version 2. The old style, we basically had to define it in this way. The new one basically looks similar. We just use the dash here. If we work with trust zone, it's a little bit different because here the appropriate board file, board folder existed. This is not any longer the case. So there's only one board folder, and within the board folder, the SOC, the cluster, and the variant is basically handled. Board revision did already exist in the version 1 implementation, but here we basically added the version number at the end. That's changing, and if you do a build, you basically have to add the version number now behind the board name. And that was quick. Because I didn't have too much time. I promised I have some links here. So there were 2 cool events. So there was a meetup in Cologne on 18th of January where my colleague talked about the new hardware model. You can check the video here. There was also from Benjamin a nice Zephyr tech talk about the new hardware model, where 2 of my colleagues and someone from Intel, Anas, basically talked about the implementation here. And I also put here 2 links to the Zephyr documentation where the custom boards, the hardware, the new hardware model is basically covered. And that's it from my side. And if there are any questions, let me know.
Say, for example, migrating from 3.6 to 3.7, I'm not sure about I'm not consuming resources, but I can retain my own pin control using this, or does that also need to be resources?
You can still use your own pin control.
Okay.
Yeah.
I mean,
So that's not really updated. So the kconfig definitions, the pin control, the device trees, this is working in the same way like before. There might be minor changes. If you have defined, if you use the predefined dev kits, the board definitions from Zephyr, and it's not a problem because the migration was done for you and you just use the boards of the new version. If you have defined own boards, then some migration is necessary. The good thing is there's a migration script, a Python script, which helps you. For single core, that's working perfect. If you have a multi-core implementation, you may have to touch some things. But yeah, I have not really talked about it a lot. So my proposal is basically take a look on my colleague's presentation because he also gave the link to this Python script. If you go to script, if you go to the Zephyr folder in script, utilities, you find the board version 1 to version 2 script, and yeah, you can use it from there.
One question for multi-core boards. Let's say you said that you have a network core and you have a member core. So at the end you will get one binary file, or you will get 2 files flashed to each core. If we talk about multi-core, and it does not depend if this is on one IC or if it is spread over the board, then you're basically working with different projects. So you do a multi-project approach. So one project for the secure domain, one project for the non-secure domain on the application controller. If there's a network core, another project on the network core. And at the end, this is basically the sys-build implementation in Zephyr that could handle the compiling of different projects. And at the end, you would get a merged hex file that could be then downloaded to the hardware, and you have all the code for all the cores on your board, on your SoC.
But basically, they are running, like, let's say, 3 versions of Zephyr. So you have, if someone crashes,
Yeah, that's the case, yeah. Yeah?
The next version of the SDK will be based on Zephyr 3.7.
And NF Connect SDK. Yeah, I only talked about Zephyr itself. If we talk about NF Connect SDK, the major number is one less than the Zephyr one. So I talked about Zephyr 3.6.0. In the NF Connect SDK, we are currently at version 2.6.0. The next version, which will be released in June on our side, the NF Connect SDK, will be version 2.7, and it will use the new hardware model. It will use the current Zephyr main branch, where the hardware model version 2 is already included.
You're going to make another 2.7 when the LTS is released?
No. So at the moment, Nordic is not really following the LTS approach from Zephyr. So if LTS version is needed, then please use the Zephyr directly. That's at the moment the only way. So I think there are some discussions internally Nordic about how to handle this in future, but I have no idea about it, what the status is at the moment.
You also mentioned the 54K. That's released also from Azure.
Yeah. So there is already a version available, a -CS1 version, if you take a look on the official NCS releases, that supports already 54L, but you can only use it if you got an NDA with us, if you got the PDK from us, then you could already do some testing with that. And with the next, the next official release 2.70 will for sure add more stuff for the new pods. Yeah.
So I understand that you can use different Zephyr versions with the same
Usually, if you install the NF Connect SDK, you use a fixed Zephyr version. So that was defined by Nordic. But in principle, this is just a West Channel file entry in the West. It's not recommended because we do testing. We ensure that the whole SDK works as we intend it to work. In principle, yes. If you take a look in that West Channel file, you basically add different repositories. And there you see that we add the Zephyr fork, which we store on our GitHub page. And there we basically define which Zephyr version, which functionalities we add in our SDK. And by changing the definitions there, you could also include it from a different source. But that's, again, from our side, not recommended because we have tested our SDK, and only if you use our SDK, we can also support you. If you install something else, it's getting really hard for us to do the support because we don't really know what you have installed.
So how do you work yourself? You regularly update both Connect and Zephyr?
That's basically, when we do quarterly releases of the NF Connect SDK. When we do a new release, we take a look about the latest Zephyr version. Most often we use the Zephyr main branch. We do some cherry picking about features which we want to have early in our version, and we include it there. And the easiest way to find out, take a look on the github.com/nrfconnect. There's the Zephyr or SDK Zephyr repository, and that's the fork which we take from the Zephyr, the official Zephyr webpage. And there you also find the tags, the branches, which version of Zephyr we have included there. Yeah, I think it's time for a break. If you have further questions, feel free to come to me in the break.